Bueno, pues bienvenidos a un nuevo webinar de los que organizamos conjuntamente, Technology Evaluation Centers, it-latino.net, en este caso tecnowebinars.com. Yo soy Daniel, os estoy hablando desde Sant Cugat del Vallès, aquí al norte de Barcelona, en España, y estaré un poquito al cargo del webinar de hoy, moderándolo y gestionándolo. Al otro lado de la pantalla, bueno, en la otra pantalla y al otro lado del Atlántico, veis a Jorge García desde, desde Montreal, ¿no, Jorge?
Montreal, Canadá, sí.
Fantástico. Te escuchamos perfectamente. Bueno, ya sabéis que esto es parte de una serie de webinar que organizamos conjuntamente ambas empresas. Estaros atentos porque llevamos organizando webinars de este tipo pues unos cuantos meses y vamos a estar unos cuantos meses más haciéndolo. El webinar de hoy es en inglés, ¿vale? Aunque Jorge sea nativo español, pero por una serie de cuestiones hay una serie de webinars que tienen que ser en inglés y en este caso pues el webinar es en inglés. Así lo habíamos avisado. De cualquier forma, al finalizar las preguntas podéis hacerlas lógicamente en español y Jorge las traducirá al inglés y os contestará en inglés. Nada más, Jorge, estamos viéndote, ya sabéis, hoy Jorge nos va a hablar del informe que ha realizado en Technology Evaluation sobre la aplicación de la inteligencia artificial en el sector industrial. Y nada, pues estamos aquí deseando escucharte, Jorge.
Okay, bueno, gracias por estar aquí. And well, I'm going to start with the English presentation and hoping that soon enough we'll give the same presentation in Spanish. We're preparing the Spanish version of the report. So, well, hi, all, and thank you for being here with us today. In this webinar, I would like to present an overview of our new tech report called Artificial Intelligence Enabling Fourth Industrial Revolution. The report addresses some of the most important aspects regarding the adoption of AI in the manufacturing industry, and well, we try to cover a lot of ground on this area. Some of the aspects that we touch on the report, of course, include an overview of the discipline of AI in the context of the manufacturing industry, the general and specific benefits of the adoption of AI in manufacturing, as well as some of the different technologies and solutions available on the market. Of course, the report includes also the analysis of a survey that we conducted here at Technology Evaluation Centers, and well, we encourage you to read the report to take a look at the report. You can go and find it in the link with the presentation or directly within our web page. So with no further ado, let's start. So before we take into consideration all the facts of the survey and the report, we gave a brief presentation of the status of the market. And well, being AI a new technology, we wanted to start out asking ourselves why or when do manufacturing companies feel the need for new technology? And well, in my experience with customers here at Tech and in my previous lives, in the manufacturing industry, key reasons for companies that look for new tech include, of course, five main reasons. Of course, increasing operational efficiency is one of them, optimizing the use of resources, reducing risk, lowering operational costs, and of course, minimizing downtimes, if you will. Another aspect of it is, of course, when companies look to implement this new technology, is having the goal of innovation. Now, how this innovation manifests within manufacturing environment depends on the organization's overall goals. Some new tech may present innovation in a way of price and revenue competitiveness, while other innovations may assist in user friendliness or to boost productivity. Furthermore, many organizations also consider that new technology should be designed to positively disrupt its current field. So, if we consider all major industry revolutions, these key elements for new tech adoption seem to remain over time. Today, we can easily understand how the first and subsequent industrial revolutions came to be. Industry 1.0, for example, or the first, happened around 1784 when the steam engine was invented. This invention marked the beginning of the so-called mechanization era, where production evolved from physical strength to machine power. And mechanization was the name of the game. As machines were further advanced and the production capacity was greatly increased, we reached Industry 2.0. Mass production assembly lines were possible thanks to the use of electrical energy. Then, in the 1950s, we witnessed the birth of Industry 3.0 and the era of digital technology in the industry. With the advent of the electrical driven mechanical calculator, and of course the use of these for mass production processes, and followed by the first PLC controller in 1969, the use of electronics in assisting the assisting of IT departments in automation and production led to a reduction in human power in manufacturing and an increased massification of production. Today, we are currently facing the beginning of a fourth industrial revolution, or what we call Industry 4.0, in which the use of digital technologies for manufacturing keeps deepening with the adoption of these new technologies. So, what happens with Industry 4.0? Well, a first aspect of this Industry 4.0 paradigm is that it is being shaped by the adoption of a blend of new technologies, which we could include many of them like robotics, analytics, augmented reality, location detection, of course, cloud computing, and some that we call what we call Industrial Internet of Things, or IIoT. All of these, of course, include, in many cases, artificial intelligence. This blend of technologies lead to a second aspect of Industry 4.0, which is the use of data and consequently what we know as a lead to virtualization. Most of these technologies forming the new Industry 4.0 have a common pattern. They rely heavily on the collection, use, and analysis of data to provide simulated or virtual data-based views on the factory. That is, digitize and provide vertical and horizontal data usage integration for the factory to transform it in what we call now a smart factory, with data now being the main asset. Industry 4.0 starts when machines manage themselves to blend directly into the production process. Again, they're also integrated into a computer, communicating with each other with intelligent connectivity and enabling intelligent decisions. While previous revolutions were based on mechanization and mass production, Industry 4.0 centers itself in achieve digitization or virtualization of processes via data exploitation for analysis, optimization, and of course, further automation. Being the data the new fuel for innovation, it is only logical that the use of increasingly advanced types of analytics are becoming increasingly important over time. Today, most of the technologies mentioned rely increasingly on the infusion of advanced analytics and, of course, artificial intelligence or AI technologies to their data analysis arsenals, while at the same time, due to an increasingly tough competitive landscape, organizations in many industries keep looking for ways to gain advantage over their peers. To this end, they have turned into AI in search for ways to improve business processes, or everything ranging from production and service provision to marketing, sales, and customer care. So part of science fiction stories of the past, the terms automation, intelligence, and especially artificial intelligence have become a commonplace in the everyday language of many industries. So, in this case, What is AI anyway? Well, ideally, and what we can find in the dictionary is the capability of a machine to imitate intelligent human behavior. But known also as machine intelligence, in reality, AI technologies are essentially or involve essentially the development of algorithms and mathematical models that can ingest large amounts of data and using an iteration process or a iterative process progressively learn and adapt to improve the information outcome so that with each iteration AI learns and acquires a new skill, which in turn enables the algorithm to improve the way it performs a classification or prediction. With the right training mechanisms, these solutions can, based on data, improve over time, enabling key features. Another key feature, which is the ability to learn or self-improve. Still, in its core, AI technologies are basically a combination of mathematical models and software technologies that use data to be trained for performing advanced analysis, commonly, again, for pattern discovery or prediction. As AI technologies continue to evolve, many companies from across industries, including manufacturing, are currently evaluating, if not already adopting, AI-based software solutions to better run their businesses. Another important aspect of AI is that it blends technology contributions from many sciences and disciplines, ranging from mathematics, biological systems, computer science, which have facilitated the evolution of AI, especially for mainstream adoption. Some of these technologies, which are many, include, of course, some examples such as machine learning, neural networks, deep learning, natural language processing. These and other technologies are also a reason why AI related solutions have become relevant technologies within today's enterprise software market by diversifying and widening the use of AI, but also making it more accessible. So, in this case, we can appreciate that the development of AI initiated as an effort towards the creation of systems with similar human intelligence capabilities for two main reasons: the creation of expert systems, systems that exhibit intelligent behavior, learn, explain, and advise its users, and the implementation of artificial human intelligence within machines, the systems that understand, learn, and behave like humans. There's a specific relationship aspect of it. This summarizes the potential of AI to enable computers, machines, and other devices to perform increasingly complex activities and tasks that commonly humans perform, or even some that they can't perform. The equipment of devices with AI attach them with key flexibility and key capabilities, equipping them with great advantages over devices using traditional software solutions. So, as manufacturers adopt new technologies, so they want to improve all aspects of their production, for manufacturing, product improvement, or equipment maintenance. Among many of the technologies available, one seems to be key, one that we call the Internet of Things. A new computing and networking paradigm, IoT allows physical objects to be equipped with internet connectivity and thus enable an ever-growing number of devices to communicate and, more importantly, to generate and share data. The first effect of IoT is the potential for organizations to derive significant value from data by collecting, storing, processing, and analyzing data in larger amounts. The second effect of IoT is the adoption of increasingly advanced options for performing analysis over larger and more diversified types of data, such as predictive analytics, data mining, and of course, AI. The IoT phenomena has made it possible for common users to interconnect all types of devices and at the same time to collect and share volumes of data used by companies as a vehicle for increasing, well, of course, service efficiency, customer engagement, and for achieving higher productivity. While IoT mainly focuses on the consumer side, which means mobiles and home appliances, for example, on the industry side, a specific type of IoT has emerged, one that we call now the Industrial Internet of Things, or IIoT. Manufacturing and other industries are adopting AI technologies embedded within this narrower but still very important version of IoT. So rather than connecting consumer devices, the IIoT connects industrial machinery and devices to extract data from them. And just as with consumer products, industrial assets, whether new or existing ones, can produce even larger amounts of data. These data can be collected from anything from railroad cars, grid sensors, to small and large machines. So if properly processed and analyzed, it can yield valuable insights that can serve to trigger improvements in not only the quality of the products and services, but also the quality and efficiency of the company's entire production and distribution chain. In just a few years, the IIoT has permeated the industry and its enterprise software solutions and has become an important source of data for many industries, including manufacturing. An effective IIoT initiative enables not just device interconnection and data collection, but extensive data analysis at different levels. And this enables it to become a natural way to acquire AI capabilities. To deliver on its full potential, an IIoT initiative needs to incorporate an effective set of analytic services to act as the platform brain. So every IIoT platform, as we know it, has one. By looking at a generic IIoT framework, and this is again a very generic diagram, we can see the adoption of analytic capabilities can bring valuable information that organizations can have in three different shapes or forms. One, in a descriptive form, with the use of traditional analytic techniques, including what we already know, KPIs, charts, dashboards, so we can obtain important information points, such as real-time visibility and alerting about the current status of different aspects of production and operation. In a predictive form, with the use of more advanced analytics, mostly derived from data mining, so that we can improve the quality of the insights for planning, forecasting, and predicting. And then we have another level to that. We can add another layer in a prescriptive form, with the use of more advanced techniques such as artificial intelligence or AI that provide manufacturers with the ability to not only predict, but to anticipate, get suggestions, or even allow automatic or autonomous decisions over certain aspects of the productive chain. This last one is where AI plays a key role to the manufacturing ecosystem or the manufacturing system and takes it to a next level. So if we have to understand that in a level, let's take a look at the what we call the analytics pyramid. In a manufacturing context, AI-based techniques can provide important tools for improving production processes and supply chains. I really personally think that rather a replacement, AI is an important, yet another component of a full analytics strategy in which every type of analytics has its place. It's not a matter of replacement, but a matter of adding best services to the pyramid. From a descriptive analytics point of view, we can use it so we can describe what is my overall operating efficiency, for example, what is my overall equipment effectiveness, what is my overall machine downtime. From a predictive analytics point of view, we can use it to forecast product demand, to improve sales planning, to anticipate inventory turns. And at the top, AI-based solutions that support decisions so we can equip manufacturing companies with capabilities to predict equipment maintenance and anticipate downtimes. enable equipment with auto-diagnostic features, and even automate product quality controls. The use of AI can help fully achieve what is called a prescriptive stage, where the platform is not only able to anticipate, but also suggest or even in certain cases make autonomous decisions, with AI making it possible for manufacturers to reach even higher levels of efficiency. Furthermore, the continuous evolution of AI is now expected to render more improvements to the analytics arsenal and enable to reach, according to some experts, what we call a cognitive state within manufacturing, and not just manufacturing, but other industries, one in which AI can detect and identify the best solution to a problem and follow through two main paths, whether it's by providing analytics automation and serving autonomous decisions, or by being a companion that augments decision support for humans, providing clear decision paths and augmenting the company's ability and intelligence to make these decisions. All these capabilities combined make it possible for AI to allow manufacturing organizations to reap many benefits from the adoption of AI technologies. They stand to gain many of them in many, if not all, areas, of course, including production improvement. We can improve root cause analysis, product defect detection, manufacturing yield. In sales and marketing improvement, we can increase or we can improve analysis of sales planning and forecasting, leads scoring and classification, marketing and distribution, plan efficiency improvement with having an effective predictive maintenance over the equipment, optimizing fine-tuning equipment performance, and again, we can touch on almost every aspect of the production chain as more use cases increase over time. So with this, we follow through some of the aspects or the key aspects of and benefits of having an AI strategy around IIoT or around other initiatives that within our productive chains. Now, let's take a look at what's the state of the market and what some of the findings that we got from the report and from our study. So, what's up with the AI market in manufacturing? Well, to put us in context, let me share with you the following graph. Before we share with you a couple of insights that we got from the survey. According to a research report from Berg Insight, the global number of wireless IoT devices being used in industrial automation by 2015 stood at around 14.3 million. So as the sector was expected to see huge growth in the coming years, the same report states that this same figure is expected to see a compound yearly growth rate of 27.7%, reaching about 62 million by 2021, which is more than 4 times of what it was in 2015. Along with these technologies for connection and data sharing that they have assumed a fundamental role in nearly every human activity, an intelligence component comes also into play, which include many analytics capabilities and, of course, artificial intelligence. But it also shows us that, well, basically, automation and IoT and interconnection are here to stay and increase over time. Now, if we address this with our own research effort, well, we took our community and we surveyed them to identify some trends in the market. So these are just a couple of figures that I want to share with you that are that you will find in the report, along with other figures and more information about this. So when we ask how important is the deployment of an AI-based application within their organizations, a large portion of the survey respondents considered, as we would expect, the deployment of AI for their company to be important for organizational growth and success. A vast majority agreed that AI is very, extremely, or somewhat important, confirming the relevance of AI for these users and their organizations. It was interesting also the fact that most of these users that consider AI to be extremely relevant, I directly connected with people from an organization, IT and operation managers, and they might be key influencers for the potential adoption of AI within the company. Still, as we have seen in the past, often interest in technology does not necessarily translate into immediate action, meaning massive deployment and adoption. So this is not necessarily a key relationship. This notion was confirmed. So when we asked the question, okay, does your organization currently use an AI-based solution for manufacturing? More than 47% of our users answered that they currently do not have an AI-based solution and apparently do not intend to deploy one, which shows in this figure. This contrast with a 21.7% that already had an AI-based solution in place. So it seems like a lot of effort will be needed to get a large part of the community to elevate AI as a priority for manufacturers. So we still are in the process of initial adoption, even though we see important increase. Still, another big group of survey respondents, a little bit more than 30%, already has plans to deploy AI-based solutions within the next 3 to 12 months. While not currently benefit from AI, several organizations have already moved forward with plans for the adoption of AI on their shop floors, in their supply chains, and within their core business strategies. While it would be easy to think that the pace of implementation of AI capabilities is not necessarily strong, the combination of results turns out to show that more than 52% of the survey population already has or will have an AI-based application ready and working within the next 12 months, a pace that should not be ignored. Then, when we ask the primary use of AI within their organizations, what would they use AI for? A majority of respondents favored the use of AI directly on the shop floor for product improvement, taking it to about around 11 point, around 45%. So it is clear that most respondents want AI to be involved or used directly on the shop floor rather than use it in satellite functions such as process automation, marketing, or maintenance. This makes clear that the incorporation of AI and new technologies in manufacturing is not just unavoidable, but in many cases necessary to remain competitive in the market. So these are some of the figures that we found that were interesting from the survey report. Now, let's take a look at some of the key aspects of now that we know a bit more about the state of the market. Let's talk about the future. So when we spoke with some of our customers in the community, and we took a look at the future of AI for 2020 and beyond. So we see three main aspects that to consider, and most of them are a continuing effort. Some of the top manufacturing trends to look for in the coming years, of course, include a continued expansion of AI into more industrial areas, where AI will continue to grow and allow managing increasing volumes of data and generating better insight, as well as improved sensors and technologies within the manufacturing industry. We still see this as a growing process. It's not mature enough. There's a little bit of lack of standardization, which we would expect in the coming years. An increasing investment in robot and drone technologies. This is something that it's very interesting as more fully autonomous systems continue to incorporate new technologies in the mix. Robots and drones will become increasingly commoditized. A commoditized product due to lower prices and technology availability. We think about robots. It's still as a costly solution, but we would expect that in the coming 5 to 10 years, these will be more commoditized for not just for big manufacturing companies, but for medium to large companies to do that. Then a continuing of Industry 4.0 adoption is expected. We expect that the increasing number of companies in the manufacturing sector will adopt this new paradigm that includes the incorporation, of course, of AI and many other digital technologies. Not mentioned in the slide, but other technologies that we're looking closely to is, of course, blockchain and 3D printing, as they seem to be rapidly gaining steam within the manufacturing sector. And this could lead in the coming years to a merging or a relationship more closely tied to AI with these technologies of sort. And I think that normally I like to put a final slide as a call to action, and it's interesting that every time we spoke with customers, they ask us, okay, how do I start if I'm not related or I don't have an AI-based solution in place? What where would I start? What should I do to start? Well, there are some basic steps recommended to guide you through an initial evaluation process for the potential adoption of AI and an AI-based solution. And these are fairly simple to mention, a little bit harder to achieve, but I think it's important to take these principles into consideration. So the first, of course, is learning about AI. Taking the time to know more about what AI is and what it can do for the organization. So potential adopters of AI technologies can be aware of the opportunities and, of course, challenges to overcome. Currently, there are many sources of information available out there to learn about AI and the benefits of AI in many different industries. And well, some of these include online sources such as Coursera, Udacity, Udemy, or even free courses offered by Cognitive Class. I think is an IBM company in this case. Um, the second aspect of it is, of course, try to identify the use case. So once we have the basic knowledge, we need to take time to identify all the different areas and cases where the use of AI will be well suited for the organization. What's the base use case scenario for us? Product improvement, production optimization, quality control, etc. Beginning with a simple and straightforward use case and planning to do incremental scaling really can help to measure and appreciate clearly the value provided by AI within the organization. A common advice that I do, not just with AI, but other software areas, is to identify a small yet relevant use case to work with and then start from that and grow. Normally, what we call it is, well, think big, start small. Once we do this, uh, we need to assess the value of the AI implementation. So if we have a use case, this will help us now that we identify the potential use case uh, to assess the business and financial value of the organization's specific implementation of an AI solution. We need a justification. We need to show that that we can have value from it. So prioritizing key value measurements and metrics can really go a long way to evaluate the relevance and the overall value of the AI project and the financial and strategic value within the organization, return of investment, total cost of ownership, et cetera, et cetera. Aside from other values, strategic and not necessarily quantitative, but qualitative values as well. And finally, well, let's assess our own internal capabilities and readiness for the adoption of AI. How mature are we on the pyramid scale with the use of analytics? And even if we need to realize this, so we should know and be aware of what are our internal tech and business capabilities so we can deploy before starting the implementation of an AI-based solution. We need to know how ready are we to go and start this adventure. These and other considerations can play a key role in increasing the chances of succeeding and making an AI endeavor to be successful within any organization. And it can help to experience, of course, less disturbance, of course, less stress, and money spending in the process. So these are some of the elements that we have within the report. I hope this was interesting and useful for you. You're invited to download the report. We have, aside from the material that we show, we have other material as well, some of the key players in the market, some of the key features that you need to consider when considering that you need to take into account when considering a new AI solution, et cetera, et cetera. So from my part that is that is all, and I'm opening up for questions. Thank you. Gracias.
Muchas gracias, Jorge. Bueno, como os he comentado, podéis plantearnos las preguntas en español y Jorge se las autotraducirá en inglés para para que quede grabado así. ¿Eh? Podéis plantear las preguntas vía micrófono. Si accionáis la mano levantada que aparece en el panel de control, yo os doy acceso vía micrófono. Si queréis plantear la pregunta en inglés directamente, pues mejor, y si no, pues la hacéis en español y ya la traducimos. También podéis plantear vuestras cuestiones por el chat. Recuerdo, podéis levantar la mano accionando el iconito levantar mano que aparece en el panel de control de GoToWebinar y yo os abro el micro. No se va a ver la webcam, o sea que tranquilos, podéis plantear las preguntas tanto en español como en inglés. Bueno, Jorge, vamos a ver, has mencionado, yo creo que aquí una de las cosas críticas es hablar de los casos de uso, digamos, particulares que se están utilizando más, ¿no? Has mencionado algunos, mejora de la productividad, la calidad. Es decir, si tuvieras ¿qué tres casos de uso se te vienen a la cabeza como los primeros que se están implementando? Porque, por ejemplo, hemos hablado en varios webinars nosotros de mantenimiento predictivo, por ejemplo, ¿no? La detección de anomalías y, digamos, la aplicación de algoritmos cada vez más complejos para poder prevenir, por ejemplo, averías, ¿no? En máquinas de producción. Esto entiendo que es así. ¿Qué otros casos de uso, además del mantenimiento predictivo, consideras tú que son los primeros, digamos, para empezar?
Bueno, esto va a depender mucho de la situación de la propia empresa y de las capacidades técnicas y de recursos con los que cuenten de momento. El mantenimiento preventivo es el primer caso porque es un caso que incide directamente con la eficiencia de la operación. Entonces, que era lo que comentábamos al principio de la presentación. Uno de la justificación fundamental tiende a ser la eficiencia en la operación, la reducción de costos, etcétera. Entonces, por eso es que el mantenimiento preventivo es tan importante. Pero tenemos otros, por ejemplo, como las pruebas de producto, la automatización de pruebas de producto. Ese es también un ejemplo importante porque normalmente las empresas, sobre todo empresas que tienden a producir material o productos que son muy tecnificados, requieren, sus pruebas son muy costosas. La automatización en las pruebas de producto tiende a ser también un elemento clave en el ahorro de costos, por ejemplo. La eficiencia en el desarrollo y en la mejora de producto, ese es un segundo caso también importante. Y en ella podemos mencionar, por ejemplo, tecnologías como los famosos digital twins o gemelos digitales, en donde el diseño se hace a través de una representación virtual utilizando inteligencia artificial de los productos para establecer, por ejemplo, detectar mejoras, detectar defectos, detectar mejoras en diseño, etcétera. Y un tercer caso en este sentido podría ser el uso de inteligencia artificial para la personalización de producto. También es algo que se está dando mucho, que es la detección por medio de la recopilación de datos sobre cuáles son digamos las tendencias del usuario sobre la mejora del producto y no en términos, por ejemplo, de uso, ¿no? Cómo se está usando el producto, cuáles son los puntos débiles y fuertes de un producto. Se ponen sensores en los distintos productos. Hay incluso casos, en el caso, por ejemplo, de los automóviles, cuáles son las costumbres de uso para hacer un producto más eficiente basado en datos reales del uso. Entonces, esos serían, yo creo que los tres casos que más reconocemos, cuando menos con nuestros clientes, o cuando menos con nuestra comunidad.
Bien, entiendo también que todo lo que es la analítica de datos de sensores, ¿no?
Ujú.
Digamos, es otro de los aspectos críticos, ¿no?
Sí,
En
sí,
todo
sí.
lo que tiene que ser la aplicación de la inteligencia artificial en este sector.
No, no entendí la pregunta. ¿Te refieres a qué tan importante es o...?
Bueno, todo lo que es la analítica de los datos que ofrecen los sensores en el Internet de las
Bueno,
cosas.
definitivamente, por eso comentábamos, definitivamente una tecnología que ha derivado en el mayor uso de la inteligencia artificial, porque la inteligencia artificial existía, por ejemplo, en el uso de robots para la masificación o las líneas de producción, pero efectivamente el uso de sensores o el uso de lo que conocemos como computación edge, en este caso, que es la recopilación de datos de sensores, ha beneficiado enormemente la incorporación de la inteligencia artificial porque se tienen datos o se colectan datos que originalmente a los cuales no se tenía acceso. Pero una vez que se colectan esos datos que son a gran volumen y mucho más diversos, requieren técnicas diferentes para poderse analizar y requieren obviamente también de una mayor eficiencia. El hecho también de que se requieran datos en tiempo real hace también que el requerimiento de nuevas técnicas de análisis, como en este caso la inteligencia artificial y el entrenamiento de estos sistemas, sea todavía más importante. Entonces, definitivamente el uso de sensores es uno de los principales motivadores del uso de la inteligencia artificial, una como consecuencia de la otra.
Bueno, Alejandro, has planteado una pregunta vía escrita. Si quieres plantearla vía micrófono y en español, ya ves que estamos en el turno de preguntas en español, pues encantado de escucharte, Alejandro Ellín. Y luego, os recuerdo, tenemos unos minutos todavía aquí a Jorge. Si queréis plantear alguna pregunta, animaros a hacerla directamente en español, levantando la mano, accionando el botoncito levantar mano del panel de control y yo os abro el micro. No, solo se oye el micro, o sea que tranquilos, no se ve la webcam. Bueno, entiendo, Jorge, que algo realmente importante hoy en día es ir poco a poco poniendo en marcha pequeños proyectos que den resultados rápidos, ¿no? Eso es una de las
Sí.
claves, yo creo, para afrontar este tipo de tecnologías, ¿no? Es como entiendo que lo está haciendo la mayoría de empresas.
Sí, y yo creo que esto tiene una historia previa a la inteligencia artificial. Originalmente, por ejemplo, si hablamos de analíticos, originalmente los proyectos analíticos tendían a ser muy grandes, ¿no? En lo que ponías el data warehouse, eran proyectos muy grandes y muchas veces, o bueno, en un número de ocasiones fracasaban. ¿Por qué? Porque efectivamente no se tenían resultados rápidos, la sensación era que no había un resultado, pasaban meses y no teníamos un resultado, y eso funcionaba mal de dos maneras. Una, se perdía el apoyo de la dirigencia, que eso es muy importante en un proyecto, el tener un buen apadrinazgo de la dirigencia de una compañía, el soporte necesario, y por otro lado, efectivamente, pues no había una eficiencia en el uso de los analíticos salían demasiado tarde, etcétera. De ahí, derivado de muchas tecnologías, y eso está mucho a discusión sobre las tecnologías Agile o las tecnologías ágiles, si es Scrum, si no lo es, si es RUP, etcétera. Esto ha ayudado a que empecemos por casos de estudio muy concretos, analizamos, y esto era parte de las indicaciones que ofrecíamos al final. Esto normalmente se aplica ya a un mayor número de soluciones de software, que es, vamos a identificar un caso de uso concreto en donde realmente, que esa sea la necesidad básica, es donde podemos aplicar, es una aplicación clara de la tecnología, en donde podemos fundamentar su aplicación, podemos calcular el valor que vamos a obtener y también podemos obtener resultados rápidos. Al hacer eso, garantizamos que la adopción también, el índice de adopción de los usuarios sea mayor. Por lo tanto, sí, o sea, es una manera común actual de instalar analíticos en donde hacemos un proyecto pequeño, garantizamos el éxito de ese proyecto y lo hacemos. Hay dos formas, podemos crecer verticalmente, es decir, adicionar nuevas características en cada iteración, o bien crecer horizontalmente, es decir, crear réplicas de ese mismo proyecto hacia otras áreas de negocio o hacia otras áreas de la propia compañía para reproducir el efecto de esa tecnología, en este caso de la inteligencia artificial.
Bueno, y Jorge, me gustaría saber, ¿el estudio está basado en empresas de Estados Unidos o de Canadá o también incluye empresas del ámbito hispano, ya que estamos?
No, en este caso, esta es una conversación que tuve con algunos los lectores del reporte, los primeros, y creo que, bueno, la comunidad que se evaluó por ser en inglés fue la comunidad básicamente Norteamérica y parte de Europa y Norteamérica. En su mayoría la comunidad fue, digamos, un proyecto global, sin embargo, la mayor parte de la comunidad se encontraba en Norteamérica, hablando en el caso anglófona, la parte anglófona de Norteamérica, que es Estados Unidos y Canadá. Eh, Estamos en el proceso, obviamente, derivado de eso y de discusiones con algunos lectores y gente que está interesada en Hispanoamérica, Latinoamérica, en ampliar nuestro horizonte hacia allá. ¿Por qué? Porque efectivamente el desenvolvimiento de la industria del software es totalmente diferente en Norteamérica y en Europa que en el caso de Latinoamérica. Entonces, efectivamente, sí, es un estudio en donde nuestros datos corresponden más a una comunidad norteamericana o anglófona en este caso.
Muy bien, Jorge, pues vamos a dejarlo aquí. Muchísimas gracias por tu tiempo y nada, te esperamos en el próximo webinar tuyo que será presentar el informe cuando esté traducido al español.
Exacto, en eso estamos y estamos a punto de turrón, como decimos. Entonces,
Muchísim-
esperemos que esté listo pronto.
Muchísimas gracias, Jorge.
Gracias, hasta luego.
Bueno, y a todos vosotros, muchísimas gracias por haber asistido. A estaros atentos a próximos webinars que organizamos conjuntamente itlatinotecnowebinars.com y Technology Evaluation Centers sobre diversos temas relacionados con las IT. Un saludo desde Sant Cugat del Vallès, aquí al norte de Barcelona, y hasta la próxima. Adiós.